Hello and welcome to another episode of my Quest System series. Before we start today's episode, I first wanted to tell you that I upgraded my engine version to 4.14.2, so please do that as well if you want to follow the series. So we left off creating our master enemy blueprint and also finishing the animation blueprint for our spider, but our enemy still needs some behavior, and the last time we did that for our NPC, we set it up using blueprints, and this time we're going to do it a bit different using a behavior tree. Let's jump right into it, go to our blueprints, characters, enemies, and here we will right click, and under artificial intelligence we will select the behavior tree. Call that enemy behavior tree and open that up. Here we've got a root. Basically this is where our behavior starts, and then we can drag off of that and add selectors, sequences and other things to our root. But what our behavior tree also needs is a blackboard, which basically stores all of the variables that our behavior tree can reference in order to execute its functionality. Let's hit the new blackboard here, minimize the tree, and we've got a new blackboard data. Rename that to enemy blackboard. Then go back to your behavior tree, and here you will be asked to select a blackboard asset. Select our enemy blackboard here. Now you can tap between the blackboard and the behavior tree using the two buttons here. Let's go to our blackboard first, and we will need to create some variables here. Those are called keys, and you can create new ones by hitting that little plus icon here. Then you will be asked to select a type for that. Our first one will be a boolean called isDead. Then we will create another one of the type float, which is called patrol radius. After that we will need a vector, which is the original location. And then we will create a new vector, which will be called move to location. The behavior we're going for right now is that we want to specify a patrol radius for our enemy class, and then we will find a random point in the patrol radius around the location you originally placed the enemy at in the world, and afterwards we're going to move to that location. So let's go to our behavior tree here, drag off of the root, and we will add a sequence. A sequence basically means that you can add different tasks to that sequence. You will first execute the first task, then go to the second one, and when that's completed to the third one, depending on how many tasks you want to add. If you drag off of the sequence here, you will see tasks, and there are some default tasks that you can use, but you can also create your own ones, and we will have to do that right now because there is no task to find a random point in a radius here. So just hit that new task button here, and it will be created. Then you can give it a node name that will appear, so that will just be find random point. Also, if we minimize that, you can see that our task still has a weird name, so let's rename that to task underscore find point. And if you right click, you can search for event execute, event receive execute AI. So this will fire when you call this task. Also, we will need some variables to communicate between this task and our behavior tree. Every time you want to do that, you need to create a variable of the type key selector, blackboard key selector, and set that to editable and expose on spawn. That way it will show up in our behavior tree when we call that task. Okay, now let's give that a name. We first want our starting location, and then we'll create another one which will be the radius. Also make that editable and expose on spawn, and finally we will need an out location, so that will be the point that we found using this task. It will also be a blackboard key, editable and expose on spawn. Alright, so when we receive the command to execute this task, we want to drag in our starting location, Right now that is a key, and we want to get that as a vector, because we will know that it will be one. Then right click and type in random point, get random reachable point in radius. The origin will be our starting location, and it's also asking for a radius, so let's get our radius. And this time we will need to get it as a float. Connect it to the radius. Now we also have to set our out location. Drag it in and just search for set as vector. Connect the return value here. Connect it to the execution. And when your task is complete, you'll also have to call the function finish execute and check the success boolean. Compile and save. Now we can close that task and go back to our behavior tree. If we drag off of our sequence now and expand the task, you can now see the task we created, task find point. So let's select that. Here it's asking for a starting location, radius and out location. And we can specify variables from our blackboard here. So the starting location will be our original location, radius will be our patrol radius, and the out location will become our move to location. After we found that random point, we want to move towards it, so drag off of the sequence once again. Under task, search for move to. Here it's asking again for a blackboard key that will be either the vector or the actor that you move to. Here we can select our move to location. And afterwards we will add a wait node and wait for around 3 seconds. You can also give it a random deviation, meaning if you set that to 1.5, it will wait for a random time between 1.5 seconds and 4.5 seconds. Okay, save it. That's the behavior we want to do for now. Later we will come back in here and extend our functionality. So we can close our behavior tree now. Go to our master enemy and here create a variable that is called patrol radius. Make that a float. Let's give that a default value of, let's say, 1000 units. Also we will add event begin play here. So when the game starts, we want to get AI controller. The controlled actor will be ourselves. Drag off of the return value and search for run behavior tree. That means we just start the tree that we can select here, but let's actually promote that to a variable. Call it behavior tree. Just in case that any other enemy class should use a different one. Now we also have to worry about our blackboard variables, because we have to set our starting location and our patrol radius. To do that, just right click here and get blackboard. Then you can drag off of that and set value as vector. Now it's asking for a key name and the vector value. For the key name, just search for make literal name. And you can open up your blackboard. It will be the original location, so we get the entry name of the key. Copy that and paste it here. And for the actual value, we want to get actor location. Alright, then drag off the blackboard once again and this time set value as float. For the key name, again, we will make a literal name. This time the name will be patrol radius. Just copy and paste that. And the value will be our patrol radius variable. To test our behavior, we also want to select our behavior tree variable and give that a default value. So select our enemy behavior tree. Compile, save and play. Now you can see our spider is running around to a certain point, there it waits for some seconds, and then it will move to a different point. Okay, that's it for some basic patrolling behavior of enemies, but our spider should also react when it sees the player and try to attack him. So that will be the next step that we have to do. In our master enemy class, we therefore need to add a component of the type pawn sensing. Select that, and we don't want to use hearing. Set the hearing threshold to 0, as well as the other hearing threshold here. The side radius will be something like 1000. Hearing max sound age also 0. Uncheck the hear noises. And then you will need to specify a peripheral vision angle. I would suggest you use 45 degrees. You can actually see what the cone will look like by going to your viewport and selecting the pawn sensing. So our spider will react to every pawn that it sees in this cone. It's just looking good. Then let's go back to our blackboard. We need some new variables there. Add a key of the type boolean called has seen player ? And then we'll need another one of the type object, which is called player. Actually, you cannot do that much with an object, so you can expand the key type here and under base class select actor. Go back to our enemy behavior tree, and we will need to change the way it works right now. So off of the root we will add a selector. A selector basically means that you can give it some children like the sequence, and you can give it the next one right here. It will first try to implement the first children, and if that fails, it will go and execute the next one. Also, we only want to execute our patrolling functionality when we haven't seen the player. So to do that, right click on the sequence node here and add a decorator. Then just select blackboard and you will get a blackboard base condition, which is something like a branch in Blueprints. Select the base condition and it's asking for a key. So we will select the has seen player key, and we only want to execute the functionality if it is not set, meaning that it's false. Further, there is an observer, a boss variable here, and you can select the type for that. That basically means what should happen when at some point our has seen player variable is set to true and not to false anymore. If you set it to abort self, you can see all the nodes that are marked green here. And for example, if you're in the state of moving to the location and suddenly has seen player will be set to true, it aborts and will go back to the selector and then to the next node that you place here. That means we can add another node here. Let's add another sequence. Now this sequence will basically represent what happens when we have seen the player. And the only thing we want to do right now is move to. The blackboard key will be the player. Okay. Save that, and that's it for behavior tree. We also want to go back to our master enemy class now. Give that a new variable called has seen player ? Default will be false. Then you want to select the pawn sensing component and add an onSeePawn event. So when we see a pawn, we want to check whether the pawn equals the player pawn. So get player pawn. Connect that. And we also want to check that we have not seen him already. So has seen player and connect that with a not boolean. Then connect it to the end and afterwards add a branch. So if it is the player that we are seeing and we have not seen him already, we want to set has seen player to true. Then get our blackboard and set value as bool. Again, we will make a literal name. Go back to our blackboard and copy the has seen player here, just so we don't do any spelling mistakes. We will set it to true. Afterwards we want to set value as object. Again, make literal name. The name was player. Just check it right now. Yeah, it's player. And the object will be the pawn that we sensed. So that's it for our blackboard variables, but something that is also common for most games is that enemies become faster when they see the player and try to move towards him. To do that, you would just have to drag in the character movement component. Let's actually check what the maximum walk speed is right now. It's set to 200, so we can drag off of that. Set max walk speed, and you can double that to 400, or let's do 500. Okay, compile, save, and we should already be able to test. So, here's a spider. Let's wait for it to move towards us here. Now it sees us, it starts to move, and now it will follow us. And you will see that it became much quicker. Alright, however, our spider is not attacking currently, so that's the next step that we'll do. Again, we will start to add some variables to our blackboard. The first one will be a float with the name attack range. And we want to create a boolean that is called in attack range, question mark. Okay, save it, and we can close the blackboard for now. We still need to create our attack animation, so let's go to the Infinity Blade adversaries, enemy, great spider animation. So I've got that spider attack animation, right click, create anim montage, call that montage underscore spider attack. Let's double click. That's our animation. If you scroll down, you can see notifiers. Basically, that means that you can fire events at some point in the animation, and we want to fire one when the claws of the spider should hit the player and that we can deal damage at that point. It's approximately at frame 42. Right click on the notifiers tab here and add notify. Then go to new notify. Can give that a name, attack notify. Okay, save it, and that's it for now here. Let's go back to our master enemy and create some variables here as well. First one will be attack range, which will be a float. Default value should be something like 50, at least for our spider. Then we will add another one, and that will be the attack montage. That will be the type montage, anim montage reference. Compile and save. Default value here will be our spider attack. On event begin play, we want to set another value as float. Open up our blackboard again and copy over the attack range. Make literal name. Paste it. Connect our attack range. Afterwards, we will right click and add a custom event. First one will be called launch attack, and the second one will be attack notify. Compile and save that. What we also want to do is to call our attack notify when that montage is playing. To do that, you will have to go back to your animations and go to the animation blueprint. Again, go to the event graph here. And if you right click, you will see the category add anim notify events. Expand that, and here you will have the attack notify. So when that is called, we will get the enemy and call the attack notify there. that's it for the animation blueprint. We can close that. Let's go to our enemies folder and we will duplicate the task find point. That will be the task distance check now. That task will get the distance between our enemy and the player and decide whether the enemy is in range to launch an attack. So let's open that up. Remove the nodes we have here and the variables, because we will add some new ones. First one will be attack range, which will be a blackboard key selector. Also make that editable and expose on spawn. The next one will be in attack range, so that will be the boolean that this function will set. Also editable and expose on spawn. And then we need the player. What we will do here is get the control pawn, which is our enemy, get actor location. Then we will subtract something, another vector, and that will be the player, get as actor, and then get its actor location. After we subtracted that, we want to get the vector length. So that will be the distance between our two actors. Now we want to check whether it's less than or equal to our attack range that we first have to get as a float. And then we want to drag in attack range and set as bool, connect our less than or equal, connect the execution, and afterwards finish execute with success. Pile and save. Then there is one other task that we need to create, so let's duplicate task find point again. Call that task underscore launch attack. Open that up. And let's also open up the distance check again, because I forgot to give that a node name. So distance check. Now we can compile, save and close it. Let's also do that in our launch attack. Give it a name, launch attack. Remove the nodes here. Remove the keys. Another thing we'll have to do is to go back to our master enemy, to the launch attack event, give that an input of the class task launch attack reference and call that attack task. File and save, then go back to our task and we will just get the control pawn, cast to master enemy and then call launch attack. The attack task will be a reference to ourselves. And then we want to add a custom event in our task called on attack launched. So when that event is done, and then we want to finish execute. File and save, close our task here. And let's go to our behavior tree. Drag off of the sequence, and first we will call the distance check. Task distance check. Attack range will be attack range, in attack range will be in attack range, and player will be the player. So now our boolean in attack range will be set either to true or to false, and we only want to move to our player if we're not in range already. So right click, add a decorator, blackboard base condition, which will be that in attack range is not set. And after we move to the player, or if we are already in range, we will call task launch attack. Save it. Go back to our master enemy because we have to implement our two events here. Let's do launch attack first. Before we do anything else, we want to turn towards our player. So set actor rotation. And the new rotation will be find look at rotation. Start will be the actor location of ourselves, and the target will be the actor location of the player character. Connect that here. Now we've turned towards the player. Afterwards we want to play animation montage. Drag in our attack montage. And now we want to wait until that animation is finished. So get the sequence length and add a delay node. And after that's finished, we want to drag off of the attack task and call onAttackLaunched. Alright, connect that up here. And save. Now we still need to implement the attack notify. And here we will add a line trace for objects. So we will shoot a line in a certain direction and see whether it hits something. We'll just do that to check whether our enemy is still in front of our player, and if so, we can deal damage. If not, the attack missed. The start will be the actor location of ourselves. For the end, we want to get actor forward vector, the vector in the direction that our enemy is facing at currently, then multiply that by a float, promote that to a variable, call that attack distance, and the default value for that can be something like 200. Just some value that I found out experimenting with it. Now we want to add that to our actor location, plug that in as the end. We want to check trace complex, make an array for the object types that we're trying to trace for, and that will only be pawns. There will be no actors to ignore, and let's select a draw debug type here, so for duration, and save. Then we get the hit result here and break that. Drag off of the hit actor and we will apply damage to the actor we hit. Connect that up here. It's asking for a damage, let's promote that to a variable as well. Call that attack damage. We can set it to something like 20. Also the damage causer will be ourselves. And that's it for our two events. Let's actually see whether that's working right now. So when we play, here's our spider. It's walking around and waiting some time. Then it will find a new location. Now if the spider sees us, it will walk towards us, launch its attack. See, when it hits us, we are dealt 20 damage. If we dodge the attack, nothing will happen and the spider will follow us again. Here you can actually see the attack trace. And that's it for our basic spider behavior. However, currently our spider would continue to chase and attack us even if it's already dead, and that's something we don't want to happen. To fix that, we will need to go to our master enemy class, add a custom event, call that onDeath. And the first thing we want to check is whether we are currently playing our attack animation. So just get current montage. Of the return value, we will add an isValid node. If the animation is valid, we want to stop it. Then we can set our isDead to true. Also connect that to the isNotValid path. Maybe adding a reroute node here. Afterwards, get the blackboard. Set value as bool. Make a literal name here. Let's see, what's it called? isDead. Copy that. Paste it. We'll set it to true. Afterwards we can get our capsule component, set collision enabled to no collision, then add a delay of, let's say, 4 seconds, and afterwards we will destroy actor, and that will be ourselves. Okay, so our player has no way of dealing damage right now, so just on event begin play, after we did everything here, we will add a delay of, let's say, 12 seconds, and afterwards call on death. Just some debugging functionality to see whether it's working or not. Another thing we'll have to do is go back to our behavior tree and change the way it works here. So let's move the selector down here, and before we will add another selector, connect that to our first one, and then select the second one, add a blackboard condition. It will be is dead, but only is not set. The notify observer will be on value change, so when our is dead boolean is set, it will directly react to that, and the abort method will be both. So you can see all of the states down here. If we are in one of that currently and our is dead is set to true, suddenly it will abort and the selector here will fail, and because there is no other node right here or right here, the selector won't do anything. Okay, so save it, close it, and let's play. So enemy walking around, if it sees us, moves towards us, tries to attack us, and now it was killed. You could see the animation and it was deleted. Alright, that's it for this episode. I hope you like it and see you in the next one.